Hi, Jose and Ann. Hi, everyone. How are you? I just jumped off I just presented at the Live at 5 session for the cybersecurity students that are competing on Saturday. We have a California Mayor's Cup on Saturday. Moreno Valley College has a team that's competing, and I hope they do well. And also RCC also has a team that's competing. So while we wait, you can check out Canvas. In the announcement, I put in some information about the programming challenge for cybersecurity. So if you're up for the challenge, it's happening on the 20th of March, in which you can test your programming skills, and it's for the supply chain sector. So a lot of the employers, sometimes they show up to these events to kind of scout out, certain talent. So it's a good opportunity for you to, practice and get some experience for your portfolio. It's also very important that you keep up with your portfolio and just try to document the type of experience you have, especially from a student perspective. So, okay. So I think we got some people joining us. We'll give everybody a few minutes. So check out Canvas and also download the lab. And then I'll talk a little bit about last lab and then catch you up with this week lab. And while we wait, I'm gonna go open my folder. We have a few minutes if you have any questions or anything you'd like to bring up before we start. No questions? So something to also keep in mind, right now, spring is a good time to start looking for internship opportunity. It's usually posted everywhere for major companies. I encourage you to look at those. Even though sometimes you feel like the internship might require a lot of skills, but just apply and see, even if you go through the interviewing experience, you can gauge what employers are looking for. And summer is a really good time to kind of start your experience. Do not wait until you finish school, like the end of your bachelor, because it's gonna take about 6 to 8 months to kind of at least get your feet wet with interviews and get through employment. If you start planning like during the first 2 years and then going into the third year, every summer, if you start doing some internship, by the time you graduate, you have a solid set of experience and you can start negotiating for higher salary. And that's my word of advice. I've seen a lot of students that gone through and build their experience throughout their time in school. That really helped them when they finish school and be able to get jobs, because a lot of a lot of people wait till the end and they're gonna tend to have a hard time finding work because they just didn't have that basic experience to start with. So if in any case that you need to get help on your resume and things like that, I will put in her email. And Nikki Cook is the one from Moreno Valley College. She can set an appointment to go over your resume to help you build some of the skills that you need in case you have an interview. So you can tap into the resources. And at RCC and Oracle, it's the same thing. They have a dedicated individual that handles that. Okay. All right. So with that said, I'm gonna get into screen share real quick. And I mentioned earlier, the supply chain security challenge is here. You can read the information and find out if you wanted to, you can register by clicking the link, or if you need more information, you can email them. This is a good opportunity, okay? All right, so before we get into this week lab, which we are gonna work a little bit more on branching and LC-3 instructions, I want to touch back on last week lab and some of the concern and questions you had regarding last week lab. Okay, so in lab 3, so at the beginning of lab 3, we had gone through and we talked about subtraction. We saw how LDI works and how STI would be used at the end of the program. And when you simulate this program, you would see a little bit more on how things are moved between the registers. Yes, question? But in this week, what you're gonna see is we are gonna use the set value button, okay? And be able to set up a program and then input in the value to be able to determine if our program is working properly when you run it. Now, from the lecture, we talked about how we copy the register. So I saw in the comment for the lab assignments that you submitted, there are quite a few of you struggle with this one because you weren't sure how to approach it. The tricky part to this one is that it has 2 areas that you have to address for the last week lab. The first area is you need to be able to copy the value for these labels. So you would fill the labels on the bottom. And for the copy, you simply are going to add the 0 to the register and be able to copy it across. And then at the end, you have to store it back. But when you add this, as I mentioned in the lecture, 4D is a hexadecimal that's larger than 5 bits that's allocated for the literal part of the instructions. So what you have to do is you have to break this into 2 lines, okay? So you're gonna add half of 4D and then for the first line, and then again, so that should be like 2/6. And then you're gonna add another 2/6 to make it a 4D equivalent in hexadecimal. And as you do that, what will happen is when you move it, you are able to store it within the 16-bit. Otherwise, it's going to overflow and it's going to throw an error. So this kind of, emphasize the understanding and how to set up the instructions for this. Now, if you want to go through the actual code itself, right? If I have time at the end, I'll come back to this and we can manually write it together. And I also saw in your lab that many of you didn't finish this program number 6. I had written out the program with the comments for you. So when you test it, you simply write out the program. And in this program, what it does is it actually uses a function. And this function is doing subtraction. So when you go through each line, you would see that we're doing 2 complement and then we subtract. After it subtract, it goes through the branches. So basically it's implementing if-else statement. So if the value is negative, it's going to put it into register 3. and then it's going to trigger the string that the value is negative. If it's positive, then it's going to add it to register 3, and then it's going to go to the positive label, which is going to output the positive, the value is positive, and so on. So basically, we're doing a comparison, and in order to call this function, you simply do a JSR, which is you just call the subroutine. So in assembly, you use label for these things, and so we simply use a compare label to define our function. And then when we need to call that function, we just use a JSR and the label name. So the way that you would write a function in a program in your project, you would likely need to have multiple functions. And in various part of your program, you would be able, you can have it all called up here, or in various part of your program, you can call the function. So we will practice more on how to implement the function. But for number 6, you simply write the program. And when I look at your lab programs that you submitted, if you completed the number 6, some of you just simply have syntax error, right? Like typing it correctly. So when you're looking at the errors, it shows you what kind of error you have. You would need to go back to that line and fix your typo. And if it's not recognizing like origination address, possibly because you're missing a period. If it's not recognizing your strings, maybe you didn't type strings correctly, or you using the new line, your escape sequence wrong, right? So make sure the proper quotation marks and all of that, some of the very simple basic things in programming, and checking those things. So when you test this particular program, the beginning of this program, it does the ASCII conversion. And keep in mind that whenever we work with assembly, we work with encoded characters. So when the user inputs something in text, in assembly level, we have to convert it to a hexadecimal value, or a value that the computer understands. And from week 1, we talk about how there is a 30 offset. We need to subtract the value with 30 to bring it down to the number that the computer would register for that value in hexadecimal equivalent. And then in order to output, we then would add 30 hex to convert it back so we can output it in ASCII. And it depends, most of the time when you work with assembly, you deal with the ASCII encoding, but in some languages you might use like UTF-8, etc. And when you don't have a compiler to handle all of this, you have to do this manually. So for your project, you have to understand how to be able to do ASCII conversion for user input and convert it back for output. So keep in mind that this is going to be something that you need to implement for your project. And if you don't know specifically, how to approach it, make an appointment to see me and I'll walk you through the section or the line that you need to do that. And there are several approaches in this. So in the future lab, you're going to see that we can approach it this way, where we would do it, with the conversion like this, or we would do it like the first lab that you've done, or we can attempt it in multiple lines. So it's really depend on the developers. And then I also got comments when I read your improvement for this program, what do you want? And many of you are very creative and knowledgeable in this, on how you wanted to expand this program to handle negative values, how you wanted to streamline this program a little bit more to make it more efficient, etc. So it's very interesting to get your input on how a program can be improved. And we always want to look at that. A program, when we write it, right, we want to come back to it and say, what can we do better? And how can we approach to solve this problem and using a better algorithm? So with this, do you have any questions? Is there any challenges regarding last week lab? Because we are going to talk about how registers store things and how we're going to look at the input and output in the next lab. Okay. So part of the questions that we're going to address in lab 4 kind of came from number 2. Okay. Last week lab, when we were looking at register 1 and 2, and you saw that, how come it's showing negative on one of the register when it should show positive 1 on the other register. And as I mentioned to you in lectures and in the previous lab, register, it's okay to look at it, but at the same time, you have to keep in mind that it's temporary. And that means that because we move everything through the register and we need to put it into a memory location where that would become permanent. So when you store is where that would be the location where you would be able to find your output. And in assembly, sometimes we might not have input and output in the console. Like today's lab, you're going to see that we are going to look at the simulator and we're going to use the set value button and add a certain location in order to achieve that. Okay. So after you do the lab today, it's going to come clearer with why number 2 was the way it was. Okay. So with that said, let's take a look at lab 4. All right. So in lab 4, for lab 4 at the beginning, it talks about arithmetic function. And what we want to do is we are going to create a program very similar to last week lab, where we would have X and Y, and we can simply use a label for that. So when you look at the criteria for the program, when it states that, oh, X is at this location and Y is at this location, just like last week, you should think about, oh, I'm going to fill those label with the given hex value. Okay. And so that means that we're going to declare that at the bottom of our program, and we want to make sure that we set up the label for X and Y. Then the next criteria that it's telling you here is that we wanted to compute the difference between X and Y. So X subtract Y, and we are going to put the result, right, in 3122, which is the subsequent location. It's a +1. It's a subsequent memory location after the X and Y label. Then we are going to place the absolute values of X and absolute value of Y in the following collocation after the X minus Y. So 3123 and hex 3124. And keep in mind that the absolute value, that should give you a clue on checking positive, because no matter what we input for X and Y, it's going to make it positive because it is an absolute value. So if I have a -2, it would become a +2. So that kind of give you a clue on how you would be able to branch in such condition. Okay. And then for the next criteria, it tells you that determine which of absolute value of X and absolute value of Y is larger. Place 1 at the location hex 3125 if X is a 2, if Y is 1 or 0, that should be 1 or 0. So we'll come back to this, or if they are equal. So here it gives you the overall summary of the 3 bullet points. X minus Y is going to be at 3122. Absolute value of X is going to be at hex 3123. Absolute value of Y is going to be at hex 3124. And we can use Z, right, as at X hex 3125. Okay. And this is a Cal State San Bernardino other university lab that I'm using. So this is what's given to the students that take this class at the university. So this is why it's important to really look at the problem that they give you and start thinking about the pseudocode, right, that you would set up for the assembly program. So for Z, Z is defined as 1 if absolute value of x minus y is greater than 0. So we know that we would branch when it's positive, right? When it's greater than 0, that means it's 1, 2, 3, 4, 5. So it's greater than 0, that means it's positive. For the second criteria here, Z would be 2 if x, absolute value of x minus absolute value of y is less than 0. So we wanted to show the number 2 at the Z location if it is negative, okay? Just like how last week when in number 6, it would output that string, right? X minus y is negative, X minus y is positive. But instead of outputting a string, we simply are going to have an output in the simulator with the numbers. 1 for positive, 2 for negative, okay, and 3 if it's equal to 0. That means that they're subtract and they're exactly the same value. So if I have 3 for x and 3 for y, then it should subtract to become 0. So we would go to Z and we would say that, oh, that is equivalent. It should show a 3 at the Z location. Okay? Any question with this? Okay. So just to expand a little bit further on this, it says that many branch instructions are conditional, which means that the branch is taken only if a certain condition is satisfied. And in assembly, we saw that in our lecture, right? We saw that the previous line, it's going to use that previous line to validate, right? So if you have x minus y is this, it's going to store it at that register. It's going to check that register just to see whether it's positive or negative or 0, okay? Now, the BRZ, we are going to use BRZ for in the case of 0. And for the target, all that means is that if the result is in the previous instruction, in the last line is 0, the instruction to be executed will be at the label location. So we saw this from exercise 6 from the last lab. If it branches at 0, it's going to go to the 0 label or whatever label you give it, and it's going to execute that section. If it branches and if it's negative, it's going to go to the negative section. So whatever label that you use here, right, if it meets that condition, it's going to go to that label, okay? And we want to be clear with our label when we write assembly, so that way, in the case where you have a very large program, you're not confused with your label, because it will be harder to track, right, with all different registers and all different labels. So try to be consistent with the label, and so that way it's easier for you to troubleshoot. Okay. Now, in the case that if it's not 0, it would not go to the target to execute, right? And then it would just pick up to the next line. It would just continue as usual. So if it doesn't meet that condition, if that condition is false, it's going to go to the next line and it's going to try to execute the next line. Okay, so that's how branching works. Think of it like if you are to check for the condition in the case of if else. And so we want to review this, right? N is for negative, Z is for 0, and P is for positive. And often we would put the lowercase, that's what you see in the example here, right? You would have BR, and then the Z is in the lowercase to show that it is 0. Can you use a capital? Sure, but by practice, we just wanted to make it that way so it's easier for us to read. Okay, so that's an example for using branches with the label. Okay. Now, sometimes you will also have branches that would have multiple condition. Okay, so BR in general is just going to branch unconditionally. You're going to treat it like a jump. So when you do a BR label 1, it will just branch to label 1 because there's no criteria for it to check the condition. Now, for the next one, it's going to check 0, negative for the NP for the positive. Or what if you use negative and 0? All that means is it's less than and equal to, right? So in the case where we have a value like x is less than and equal to 0, right? Then that means it's 0 and negative numbers. So you would have negative and 0 there. What if you wanted to go greater than and equal to? Greater than or equal to, that will be n and p. Okay? I'm sorry, negative and positive. So that will be negative number or positive number, no 0. And then the ZP is actually greater than and equal to, so 0 and positive. So anything that's above 0 or 0, then it's gonna branch. Okay. And then lastly, it might be 3, okay, negative 0 and positive, then it's gonna branch. So you might have a label that's it's gonna go to for these conditions where it's negative or 0 or positive. Okay. So in this lab, you likely will see that we would use these branch instructions and be able to set up our program. Now, this is a snippet example of the code, okay? So if you have an input and your input would be X at R1 and your output is going to be at register 2, that will be your absolute value of X. So when you add this, when you add R2, it's R1 with 0 and put it on R2, what you're doing is you're copying the X value from register 1 and put it onto register 2. So when you see this line, it should tell you that you are copying whatever that's in register 1 to the destination register, which is register 2. And if in this case, if it is 0 or positive, that means that it's greater and equal to 0, it's going to branch to ZP. Okay. So if I have the value for X input as 1, it's going to branch to ZP. If I have the input value that is less than 0, let's say negative 1, then it's not going to branch to ZP. It's going to go to the next line. Okay. So it's going to say it's going to go to the next line here, not R2, R2. So first complement, second complement, so 2's complement here. So at this line, your R2 is going to be negative R1. Okay. So your R2 with in the ZP, that's going to be the absolute value of R1. So the way that we see absolute value is that it needs to be higher than 0, right? It needs to be positive. It could be 0, so ZP is going to be the branch that you're going to use. Okay, I know that this image is kind of small, but you can also enlarge it, right? And I added this so that way that you can look at the code. So in LC3 editor, you can put in the program, and I'm going to walk you through the line by line to look at the program, what it's doing. Okay. And then after you write out the program, you are going to assemble it. Then you're going to load it and you're going to run it. Okay. Now, before we get into the detail of the program, in this one, we are going to need to set up input for X and Y. Okay. So in your simulator later on, make sure that you go through these instructions. It walks you through on how to test your program. I wrote out the step for you so that way that you would use this step to be able to test your program. Do not skip them. I saw a lot of you didn't answer the questions and you just take a screenshot and you submit that. But in the benefit of doing this in this lab is to show you how to test your program after you run or before you run your program. Okay, so run it first and then reload it and check it. So let's talk about, one second. Let's talk about the program details. Okay, so let me stop share real quick. Let me zoom in so it's easier for everybody to see. Okay, so before we started, before we start, we always know that we need to originate at hex 3000. That's always going to be the first line for your LC3 program. Okay. Now, in order to load effectively, I recommend going down to the end of the program. We're going to fill because that is given to us. Okay. So at the bottom of your program, you're going to fill based on what it's stated in purple at the beginning when it explains about the location. So in our, at the beginning here, the table tells us the location and that's what we're filling, okay? So on the bottom, you would start with the X label and you would do a dot fill, okay? Hex 3120. So we're gonna fill X at 3120. Then they give us Y label, Y dot fill hex 3121. Okay. And LC3 doesn't handle symbols very well in your labels, so you wanted to use letters. Okay. So I have XMY means X minus Y. That's going to store the result for X minus Y regularly. That's going to be filled at hex 3122. Okay. My ABS-X here is the absolute value of X, and that's going to fill at 3123, subsequent to the minus. Absolute value of Y, ABS-Y, we're going to fill it at 3124. And then for the Z, which is criteria, one of the criteria for this exercise, Z, we're going to fill it at 3125. Okay. And after the data declaration, we have a .n. So that's at the bottom of your program. Okay. Most, like I said, most assembly program, the data declaration is at the bottom, including Microsoft ASM. Okay, any question with this? And you can also find this on the screenshot that I gave you. So as we start, because when you start loading, right, you got to have this label ready. Because when you start writing the code and you forget to fill, what's going to happen is you're going to get a bunch of error, right? So this is like the C++ program when you start declaring your variable, int this is equal to this, int this is equal to this, double this is equal to this. So we wanted to make sure that we fill it and we point it to the location, or we have the location for the label. Okay.
Oh, Professor?
Yes.
For the branching functions, does the placement matter?
What do you like? Oh, like as far as
yeah.
not really, because what I do is I methodically set it up where it's positive 0 and negative, so it's easier for me to go back to the label section to fix in case I need to fix. but yes, you can have like positive, negative, because when you branch it, it just goes to the label itself.
Oh, what I meant is like does it matter like in placement in line? Does it have to be a certain placement? So like it doesn't like could it be the end of the line or it has to be like in the middle of the code?
Oh, it needs to branch where it should be branching, right? Like think about a C++ program. When, so you're asking me is like, oh, where should I branch? I should branch when I need to check for condition, right? Like in the
Mm.
program, you branch when you need to have the if else statement, right? So in your program, it would have a flow, and at that point, you're controlling the flow by saying if this condition is true, then it's going to execute this. So where you branch in this program is going to be where you wanted to check for a specific value.
Got it.
Okay, so let's walk through that now. Okay, so after you fill all the labels, then you're going to load the label at the top. So we're going to do an LDI R1X. Okay, and if you wish to, you can clear. Okay, you can clear the register and then load. That's fine. And the way we clear is you can do like an AND R1 hex. Yeah, I'm going to use lowercase hex 0. So we can clear R1. Okay. And then you can also clear R2. So basically we started with register 0 and we clear it so it's like equal to 0. I mean register 1 is equal to 0. And then we load register 1 with the label X, because in this function, in the problem, it has X minus Y. Then next, we're going to clear register 2. And we're going to load Y to register 2. And it's important that you track your register, meaning that you know which label goes with which register, because down the line, it's going to be easier for you to visualize that, like what's happening at this register. Okay. So now what we're going to do is we are going to set up the ones complement. Okay. So because remember that this is, let me move this down. This is X minus Y, right? That's what we're trying to achieve. So we have to make sure that we set up the negative Y in the next 2 lines. Okay, so now you can knot it and put it back into R2. That's fine. So the way I have it, that I knot R2 and I put it in R4. So this is the ones complement. Then next, because the knot is in R4, then what we're going to do is we are going to do this, the 2's complement. So at this point, that will be 2's complement of, and so when we add R1 into R4, R4 is going to be negative R2 or negative Y. So I'm going to delete this because you can probably read that already. So when you have add R3, R1, R4, remember that negative Y is in R4 and X is in R1. So at this line, your register 3 is equal to x minus y, right? So we would have a value based on this result that would be in register. The result would be in register 3 for x minus y. Then what we need to do is we need to store it, okay, to the label x and y. So that means that x and y would have x minus y result. Following so far, any question? Okay. So now on the next line, what we're doing is we're doing a copy, right? So we're going to copy the register 1. What's in register 1? Anybody know?
Would that be X?
Yep. Thank you for that. So if you're tracking your register, and that's important because down the line when we start copying across different register, we want to make sure. Thank you. So R1 is going to be X. So we're going to copy X to register 4. So register 4 is equal to register 1, which is equal to X. Okay. So doing this should answer the question from last lab when you need to copy all of those values for the all those variables. Okay. So what are we doing? We need to set up the absolute value of X. Okay. So here, what we're doing is we're doing a branch 0 positive. Okay. And we can put it to ZPX. Hold on one second. Let me check my label. Yep, I have it. Okay. So we're going to branch to this label, and in this label, we're going to do something, right? It's not a fill. It's actually a label where we're going to execute something there. So basically here we're doing, if it's positive, right, 0 or positive, it's gonna go to ZPX. Okay. And recall earlier that we have Y where Y is in R4, right? And R4 has negative Y. Okay. So now we're going to do a not R4, R4. That's going to be the 1 complement. And then we're going to add 1 to R4 for the 2's complement. So that will be negative R4. Yep, that brings R4, that brings Y back. Because recall, right, I'm going to flip screen real quick, that at some point you have to check for this absolute value of Y. Because if we kept it negative, it's going to be negative. So we need to make it where it's going to be absolute value. So that will be, we bring Y back. Okay. So now what we're going to do is we are going to set up the condition label. Remember earlier we tell it to go to ZPX. Well, we have to do something with ZPX, right? Now, sometimes you would see the label being on the left of the first line that's of that section, that's okay. Or you can have the label and then, you know, following that section. You can tab it in to make it so that way it's easy to see, like the exercise 6 from the last lab, or you can have it like this. That's okay. As long as you can read it and it's clear to you, that's fine with me. Okay, so for the label ZPX, we're gonna store Y, or I'm sorry, yeah, we're gonna store Y to the absolute value of X. Wait 1 second, let me check my register. Copy. Oh, I retract in the last line. Okay, so when we did a 2 complement here, I forgot, we did the add R4, R1, 0. We copy X to R4, that changed. So now when we do R4, not R4, R4 here, so this is actually your R4 holds negative X. Yep. Yeah, this is why we have to follow the register, okay? So because we copy X to R4, then R4 holds X. And when we not it and we did the 2 complement, R4 now has negative X. So now for the ZPX section, we're gonna take this and we're gonna store it to another label called ABSX. Okay, thanks Ryan for letting me know. It's all right if you need to catch up. Maybe you can also look at the video later. Okay, then next we're gonna add R2. So this is, we're gonna copy, right? We're gonna copy R2 to R5. So what is R2, right? Go back up and look at R2. Your R2 was what? Y. Okay. So we basically copy Y to R5. And then here is where we branch 0 positive for ZPY. So if Y is 0 or positive, it's going to branch to ZPY. It's going to go to ZPY. Okay. Now, then we would set it up where we would have the 1's complement of R5 and the 2's complement of R5, which makes it R5 is equal to negative Y. Why didn't I wanted to change? Why didn't I use R2? Because in this case, we need to test multiple times for X and Y. So if you keep changing X and Y without copying it, you are impacting the X and Y value that was originally loaded. Okay, so that's why we copy it to another register and we use the copy version of it to be able to change it, to negative, the copy version to negative. Okay. So then, because we branch to ZPY, we gotta set up the ZPY label. So when it checks the condition for Y, when it branches, it's going to look at this line, okay, for R5. And if R5 is 0 or positive, it's going to go over here. Okay, so we wanted to continue that register in that label. So now in the ZPY label, we're going to store R5 to apps Y, ABSY. So whatever register that you use to check for the branch, you need to continue that register in the label that it branched to. Okay. You cannot just throw in any register because we use R5. R5 is stored here to another label. Then I would set up the ones complement of R5. Okay. And in this case, what we're going to do is we are going to make it subtract. So, but instead of using R5, we wanted to put it onto another register. Okay. So we use register 7. So here is where we do a 2 complement of R5 and put it in register 7. Then we add the 1 to it. That makes it register 7 is going to have negative Y. And now we need to subtract. Okay. So R6 is going to have R4 minus R7, which means it's X minus Y, right? Then here is where we're going to branch to check. So when it adds, and if it's positive, just like the last lab, it's going to go to the POS. If it's not, it's going to pick up on the next branch and it's going to check for 0. So if I have X is 5 and Y is 5, right? It's a 0, so it's going to skip this and it's going to go here. And then it checks for 0, then it's going to jump to it's going to go to the 0 label. Now, if I have negative, then it's going to skip the first 2 and then it's going to go to the negative branch and then go to the negative label. Okay. So basically it used the previous line to check, and if the condition is true, then it's go to that label. If not, it skips it and it's go to the next line. If the condition is true, then it goes to the label. If not, it's going to skip that and go to the next line. Any questions? Let me see if it holds everything together. Okay. So for the third condition, we're going to have BRn neg. So if I have like 4 minus 6, because it's a negative value, this checks true, then it's going to go to the neg, the neg section, the neg label. Follow so far? Any question? Okay. So because we branched, then we gotta set up our label. Okay. So for the positive, we first clear register 6. Yep, I will do that. You know what I'm gonna do? I'm gonna move that whole section down to the next page because that way it's all together. Okay, so in the positive label, we are to clear register 6. So when you have the and here, you clear register 6. Okay, because recall that we had used register 6 previously. Yep. So we absolute value of x minus y. Yes. So now what we're going to do is we are going to set up the third part, which is the z part, right? Where it shows 1, 2, and 3. Okay. So once you clear register 6, you're going to add the 1, the decimal 1 to the 6. So 6 whole decimal 1. And then you store it to the z label. Because in the that section where it talks about the z, okay, recall, I'm going to flip real quick this right here. This is what we're doing, this one, the first one. Okay. It shows 1 if it's greater than 0. So what we need is we need to make it where it's going to show 1 for the z if it's positive. And then we would halt because we need to end that branch. So when we do an x minus y, and if it's positive, we can go to the z location and we should see the 1. When you do absolute value of x minus y is 0, then we can go to the z label and it should show number 3, right? So that's the whole purpose in this area right here. So after the positive, we would do a 0 label. And again, we're going to clear out register 6. We're going to store 6 back to z. And we're going to halt. I'm going to double check something real quick. I think I'm missing a line, you guys. I just saw it. Yep. I'm missing a line. So before we store, we need to add a 3. Add R6 decimal 3. Add number 3 to z when subtract is 0. Result is 0.
This is to display 3, right?
Yep. Because that was the third criteria in the z section where it says if you subtract and it's equal to 0, it shows 3. Instead of using a string output, we just use a value to indicate our result, right? Follow so far? Any question? So once you add it, you got to store it to z. So in the case that if it branched to, and if it's 0, it will branch to 0, and it should display a 3 in the simulator, not in the console, okay? In the simulator at that address area, it should say a 3. Then we're gonna stop the branch. So when you use branches like this, you should halt at the end of each branch. Then we're gonna have the negative section next. For the negative label, again, we're going to clear out 6. So you started to see a pattern, right? So when you have the 3 conditions, what you do is you need to have each label for each condition when you branch. Okay. So we would then have a negative, and then we clear, we do a +2 because that was the second criteria for the Z is when it's negative, it's going to show number 2 at the Z location. So we're going to do an add 2, and then we're going to store it. Okay. Then we're going to halt.
Hey, Professor, do you mind showing what the person in the chat was talking about with the R6 is equal to absolute value of X minus absolute value of Y?
Okay, so when Juwon asks where that is, okay, that was when we had, hold on 1 second, I had put it in the comments. Right here. I just didn't put it in the absolute value, but that's where you test. Okay. That's right above the branches. So at that point, what are you doing, right? You are doing this because this is we need to make sure it's X minus Y first, and then we need to make sure that it's absolute value of X, absolute value of Y as we go through. And at that point, we set this up, okay? And it needs to check for positive, negative, and 0. So that's where you see the branches come in on these lines right here, okay? So that's when you do the subtract. Okay? And you already have the code. I clip it so that way in case I scroll further, you just have to add the comments. And practice reading it so that way you know exactly what it's doing at each line. That's going to help you. Okay. So on the last part, you just do the halt, and then following that will be the fill. Okay. So after I add the 2, I store it, I halt it, and then the last part we already talked about at the beginning. And don't forget the .n because it's going to throw an error. Anything that you missed that you need explanation for or something to clarify on this program? Okay, so I assume that everybody's good. All right, so once you build the program, let me open mine. Okay, this is the one that I screenshot for you. You can add in the comment if you wish. So we're gonna do translate, assemble, make sure we check for errors. If there's errors, it's because we mistyped something or we missed something. Now, if you wanted to make it clean, you can separate the section, right? And get it to be like, so that way it's easy for you to see. That's okay. Eric says the last branch is, do we have to use R6 to store the Z, or can we use the other register? So now let's go back and look. You don't, for all of these labels, you don't have to use R6. The reason why I use R6 is R6 was not used for the other areas, okay? And if you want to use other register, be consistent, like positive, 0, and negative, so that way it's easier for you to track, okay? I had previously used, now R6, Eric, right, was the where it stores the X minus Y, okay? And so when we end it in the positive, we clear it out and then we add the 1. But because I use R6 here, so I kept it as R6 over here. So that way I can follow like, oh, the result, if it's positive, it's going to be a +1. If it's negative, it's going to be a +3, etc. But yes, you can use other register if you track it accordingly. Okay. All right. Let's talk about assembling this. So once you assemble it, it builds from the .asm file. So make sure we save it as a .asm. We're going to do a translate and then assemble. For the last, it was more for the setting up the register 0 once rather than the 3 places more than anything else. I don't understand your comment. Oh, it was more, okay, so it was more for the setting of the register 0 once rather than 3 places or anything else. Okay, I'm going to explain to you why we clear it 3 times. Okay, because if you clear it once in this section, okay, and you don't clear in the negative, when it goes into the negative, it's still going to store the result from the last check from earlier. Okay. So if I clear it here, I don't clear it in the next section, because remember that it's going to jump to one of these, not all of them subsequently. Okay. So when it branch for positive, it has to clear, and we're going to do a +1. It might not happen for the positive. It might go to 0 instead. It depends on the input. So you have to clear it for every single section, because there are 3 conditions. So you have 3 label, and they are all different label for 3 different conditions. So when it branches to each of the condition, it needs to clear. Otherwise, it would have the residue from the last result, right? Because if I don't clear in the 0, it's going to bring whatever is down here. It's going to do a +1, and it's going to give me a different value, not 1 in the display. Okay. So okay. So each of the section, we're going to need to clear it so that way we can display 1, 2, or 3. And it doesn't matter whether you do positive, negative, 0, you know, that section can be, it doesn't matter. Okay. But I chose to do positive, 0, negative. You can do positive, negative, 0, 0, positive, negative. However, it's still, all it matters is going to be what you put inside that label section, what you want it to do. Okay, that's important. But when we branch, there was an earlier question, I think Andrew asked, when we branch, does it matter if I branch negative first or positive first? No, right? It's gonna go to the according label and trust that we have the appropriate display in the appropriate label, then it should be fine. So if I put branch Z first and for 0, it just go to 0. If that doesn't check true, then it goes to the next line. Okay, any other questions? All right, so once we assemble the program, we need to load. But before we run, I want to show you how that needs to be inputted. So the criteria for this, do not skip the information that's given to you. Okay, so put your code into the editor, assemble it without error. Okay. And then before you run the program, look at where it places the line of code, where all the labels are, everything. And in the simulator, you should use the step over button to go through the program and answer the question. When you click the step over button, what's going to happen is going to go one step at a time. So it's going to show you at the top the register that is loaded at the beginning of the program. So I'm going to do that to show you how that works. Okay. And I emphasize it many times in the semester for this class in particular. Use those buttons to kind of better understand what it's doing at a certain point. Because otherwise, when you start writing more complex program, you're gonna get lost if you don't understand what it's doing. Okay, so open up the simulator. And then we're gonna go File, Load Program. I'm gonna go to my lab 4. Okay. And I'm sorry that this is the way that they write the application. It's kind of small. I can't really do much with the size here. So first we can do the step through or step over. Okay, so here's the step over. It's next to the run button. Okay, so you notice that when we load, right, it starts at 3000, it goes to 3001 for the next line. Okay, and what it's doing is when it loads, pay attention to how the PC, the program counter and the IR is at work. Okay, and it's going to show you the top what's happening. Then next, right, it changes as when it knots it, and then next, you see how that changes, and then look at the register. So when you have it from the first complement to the second complement, the 2's complement, see how it puts the -1 into register 4? Okay, and then that's going to change. Okay, so it moves it out now. Okay, and it changes this. Okay, and then again. So this kind of slow down the run process so you can see step by step on what's happening to your program and what is being placed. So look at the PC counter at this. So it puts this address into the program counter, right? When we do a store and we store register 3 to X and Y. So what it's doing is when you're doing a store, remember how we talked about data movement? What it's doing is it's going to put the address into the PC, and that address belongs to X and Y. So it knows, it uses that, the program counter to be able to do what? To associate the value from register 3 to that location. And then step over once more, right? at the next one, that will be 6. So it goes to for the execution. So it changes with the IR. And at this time, what we did was we copy the register, right? Okay. Now, I want you to look at it and try to understand what's happening at each stage. Okay. So I'm going to reinitialize the machine real quick. Then after that, what we're going to do is we are going to, after we do the step over for B, we're going to use the simulator. You should reinitialize and, or if you use the same program, what you need to do is you are going to you can use the jump to drop down. And if you jump to hex 3000, it's going to take you to the beginning. So as you go through and you started going through the program and further, if you need to go to a certain address section, you can do a jump to. And jump to is located here. Now this, I can have it jump back into the beginning of my program, right? If you need to jump into a different area of your program, let's say hex 3225, for example, you can go to that section to see your output, your value. And that's what that jump to is for, is to be, you can scroll up and scroll down, but sometimes that can be difficult. So you can just have it jump to, and then type in the location that you want it to go to, okay, to show you in the simulator. Okay, so let me reload this program. Okay, so it's now, it shows you that you can use the toggle breakpoint, the red dots with the arrow, to place the breakpoint for the label Z, then click the program run. Okay, so when you wanted to really test and look at the program closely, if we look at this, oh, sorry, I think Z is, what is Z? 3225, I think. Let me double check. 3125. So what we can do is we can go to hex 3125, right? Oh, 30. Oh, it puts it at, sorry, it puts it at 3026, which is the subsequent one, and it fills it at 3125. So when you set up the fill label X, Y, X, M, Y, abs, and Z, right? Because X is here, even though it fills it here, the fill value is not the actual location of the address in the simulator. So here my Z is 30026, okay? And now what it tells you to do in the lab is that once you can put the toggle button, the red dot arrow on the Z, and then you click run, what's going to happen is it's going to stop right there, and it's going to show you what's in the PC. Okay. So your toggle breakpoint is here, put that there. And then when you click run, and then you can navigate to the jump to. So what happens with that is that it's going to stop at that breakpoint when it set up the Z. And then what you can do is you can go back and you can take a look at after your program is ran. Okay. Or you can do the step over and then set up the breakpoint. Okay. So to jump back to that location at Z where I put it, what happens is if you look at the counter, right, and then here it tells you that when it filled this label, it stores this register 0 and the value at the register 0 or register 0, and that would be hex, the address for that would be hex 2F4C. Okay, so now let's go back. We can undo that. Okay, then for E, it says in this step, we will test this by setting the value. And you can do the same thing for this, for the last lab, for exercise 2, 3, etc. When the one that doesn't have the console input. Okay. Now, you need to load, when you load the program, you can set in the value for X and Y. Okay. And you do not run the program until the values are set. You can click the set value button, which is the purple button that shows 1011, right? And then you can put in the set value. So in that, what you can do is you can set the location or choose a certain location to set for register 1, and then you're going to click apply. You can repeat that for register 2. So here we go. So I'm going to go ahead, before I run my program, I'm going to click the set value. Okay. And what I can do is I can go scroll down and I can set certain register to test. Why do I set register 1 and register 2? Because in my program to start with, I have register 1 and 2 for X and Y. Remember, I load. Okay. So this is a way that we can introduce input into the program. And at the beginning of our program, we have load register 1 and load register 2 for X and Y. So when you click the set value button, which is located right here next to the blue arrow, it's the purple button. Then you click the arrow drop down, you're going to tell it location. Okay. And you can also put in address location. So here, let's say that I put in my R1 is going to be 3. And you click apply. And you notice that it now loads the register with the number 3 that I entered. And you can use decimal as long, the decimal equivalent to the hex in from 0 through 9. And then I can set my second register. And then let's say I put it as a 4. Okay. Once I have set those, what I can do is I can go ahead and run. Okay. Now, this is not going to tell you the exact answer. It's not going to hold the correct answer, of course, right? If you wanted to know the output, you need to go to Z. Okay. Find Z location, and then that way you would be able to have the right output. Okay. Remember that this program is going to show a certain number. So when we have X minus Y, if it's positive, it's going to show a certain number. If it's negative, it's going to show a certain number. If it's 0, it's going to show a certain number. And that's how you're going to check. Question? Now you can also set value to the location. Okay. And so like here, see how it shows the location because I highlighted that location. Let's go to, so if we jump to the beginning of the program, right? And if we go to the Z, which is here, okay. The Z, we had it fill at 3125 and the location is 30, the address is 3026. So now, earlier you saw that I tested, so let's see, I do a register 1, okay, and then I test it at, so if I have a 3, and register 2 is a 4, so this should give me a negative number, right? Okay, and then let's run it. So recall in your program that R6 was the last register that has that store out, right? And we clear R6 and we put a number there to show whether it's positive, negative, or 0. What does it show you here? 2, right? So is that right? 3 minus 4 is a negative number. And is it displaying 2 for register 6? And register 6 store out to a label. Okay. But store outs to the Z label. Okay. So it shows us that it's 2 and that is correct. We have the right program. We ran it. And at the last step is the store from register 6 and it gives me a 2. So that's how you can introduce value to directly into the register to kind of test your program. And as it ran, this is no longer holding the input from the beginning. But we see that at the end of the program, your register 6 was to store whatever number that we added to represent positive, negative, or 0. Okay. So now that you know how to use the set value button for input, any question?
How will you do it for the online simulator?
1 second, let me check it out because each one of them is like a different thing. Which one are you using?
The online simulator.
The first one? Let me see. It is.
Oh, Professor, so when we use set value, that way we don't have to like put in inputs, right?
It is an input. It's just we manually input it. We introduce that value to the register.
Yeah, instead of asking a question and then putting
Yeah, instead of doing ASCII conversion with the console, because when you do a console input, you have to ASCII convert it. Okay. So internally, you can test this. Assembly is not designed with user interface in mind. You have to think about that. It's really designed for the OS and the compiler. So, you know, we do interface like for user and input and output so you can see how it's done and how it's converted. But assembly is meant for system. It's not, it's, you know, it's for drivers, it's for browser, it's not meant for like user interface. The user interface, we use higher programming language for that, right? So you can make buttons and things like that. So, you know, all right, let's see. Let me check out their thing real quick. Step next, finish, continue, manage labels. Clear input buffer. Oh, click on the register itself and type it in. Here, I show you. I'm sorry, I'm a little tired. It's Thursday. All right. So this is one of the ones that's linked to Canvas. So if you want to set register, right, you just click on it and then you type in the hex value. You can do like hex 0001, you know,
Okay.
and then, yeah.
And do you put the values before you run it or after you run it?
Yes, always in simulator or online simulator. Because after you run it, it defeats the purpose, right? Like
Mhm.
you don't want to introduce input after the program already executed. You wanted to introduce input so it could execute it with the input. And then you can always reset everything clear, right? So this, when you click this button, all that is it just clears everything out at 0, right? It ended with the 0. Okay. All right, let me address number 2, otherwise we don't finish. And I don't know why I'm going much slower in this semester compared to last, because I guess I want to make sure that you're clear with this. Last semester, I had like a really big class too. Okay. So as you finish number 1 and you set, I want you to test these values, 5 and 4, you know, try to see if you can input negative hex 4 and negative hex 5. Is it handling the negative? Because I saw your comment in the last lab in number 6, right? Some of you mentioned that, oh, it didn't. I tried to type in negative and it didn't because of the console. Well, can you manually input that into the register? And then, you know, is there a limit in the input? Remember that when the hexadecimal gets very large, right? Remember, we only have 5 bits to handle the immediate input. So what's going to happen to your output? Is this consistent, right? So we have to look at the little flaws in the program on how we can further improve it, because, you know, the user, from a perspective of the system and the user, that's at one point it's going to reach the peak of it, where if you have limitation to the program, you know, that's not optimized. So what you want is, I gave you the criteria to test. You don't have to screenshot all of them for me. If you test a couple of them, show me that you test a couple of them. Okay, so that way you practice. And then I wanted to proceed to number 2. If you got the concept for number 1, number 2 is a piece of cake. Okay, it's just using different label. The criteria is almost the same. Any question before we move on to 2? All right. So for 2, it's very similar to exercise 1. We're going to write an LC-3 program, and it already gave you the location for the label. We have P at 3200, Q at 3201, RES is going to be our result. That's going to be at 3202. We're going to do a P minus Q. It's going to be greater than 0, very similar to what you've seen with the Z criteria in the last one. We're going to add 2 to RES. And then if P minus Q is less than 0, we're going to subtract 1 from RES. And then if P minus Q is 0, then we're going to add 1 to RES. Okay. And when you test this, it's a little bit unlike the other one in that you have to set what RES is, right? To see, or actually you have to set P and Q and then have the expectation in what RES would be. Okay, so, all right. When you created this program, after you write it, make it, assemble it, load it, and test it with an input. So first, I want you to identify the location for P, Q, and R. So look at the left column. That's going to tell you the address of P, Q, and R. And if we assume that P is 4 and Q is 5 and R is 3, then can we test the program? Okay. So you would use the input button to test. Now, if we determine, we're gonna reload it again and we can try it with different values. So it asks you to check out different values. And then we're not gonna have time to do number 3, which happens every semester with me. Okay, so maybe we'll do it as an extra credit. All right, let's talk about number 2. I see a chat question. You will see right now. Yeah, I rename it as RES because if you use R and you use register number, sometimes that can be confusing. You can label it anything you want, really. All right, so here's the criteria. If you want to, you can comment that out in the top so that way it helps you. Okay, so I did a clear on register 1, very much like the last one. I load P to register 1. I did a clear on register 2. Let me tab it so it's easy for you to see. And then I load Q to register 2. The fill stuff is easy, so we can do that later. Then I started to set up the subtraction, just like what we did with the x minus y. So since Q is in R2, we want to subtract Q, right? So we're going to go ahead and get it to not. So that's the first complement of R2. And we are going to add a 1, and you can use decimal or hex there. That's the same. So when you do the 2 complement of R2, R2 actually stores negative Q at this point. And you can use the way that you use your label, that's fine. I put RES because I don't want to mix it up with the register. So if you wanted to use R, that's fine as long as you don't mix it up, but RES is okay. So I then would load RES to register 3. And then I would add R1 with R2. That means I take P, subtract Q, and I put it into RES. Okay. So my result is P minus Q. This one's actually easier than the last one. And very much like the last one, But in this one, we're not checking for ZP, right? It's not greater than and equal to. It's positive. It's greater than or less than or equal. So we're gonna check for P minus Q is greater than 0. If so, it's gonna go to pos. And then on the next one, we're gonna check for less than 0. So P minus Q is less than 0, then it's gonna go to neg. And what does it check? The last register that store is register 3, right? So it's gonna check, is it positive, negative, or 0? And then lastly, we're gonna do an equal. So BRZ equal, P minus Q is equal to 0, then it's gonna go to equal. Any questions so far? If we have time, we'll do number 3 together. Or you can practice doing number 3. Okay. Now you can have it this way, or you can drop it onto the next line. I'm trying to think. I think I need to store it. What does it say? Hold on one second. Let me look. We're going to add 2 to RES. Okay. So I'm missing that. Okay. Add 2 to RES. And then we should do a store here. STIR3. Let's use another label. Let's use okay. So after we add the 2, because the criteria said that we're going to add 2 to res, and then I'm trying to think if I need to use another label or not. No, I don't. And then we store it back to res. That's fine. Okay. Then for negative, we're gonna clear register 4. And can you reuse register 3? Sure, but actually I wanted to keep register 3 there so I can check. So you can reuse the register. If you reuse the register, you have to clear it, right? Just like the last one. So in this way, I clear register 4. I add 1 to register 4. I have the first complement for register 4, second complement for register 4. Then I would do a subtract, because it tells me that when P minus Q is less than 0, we're going to take register 3 or res minus 1. Okay, So no, you cannot use register 3 there. I forgot about that. So you can use register 5, 6, whatever you want, but not register 3, because we need to take the register 3 that previously here, and we need to subtract 1 for the negative. So I clear it. I have it at the register 4 as 1. I not it. I have it add a 1, so R4 has -1. And then I have add R3, R3, R4. So R3 holds register the RES -1. And then I should store it here. SCIR3 RES. Follow so far? Any question? And then if it's equal, we're gonna have it add. So when it's equal, in the equal section, we're gonna add R3, R3, 1. So when P minus Q is gonna be 0, R3 is gonna be 1 plus RES. And also we need to store it back. So we need to do an STI. R3 RES. Store result in RES. Okay. Any question? And then the rest, you just do the fill. Let me move this section down. So after you have the equal, you would do a fill. We need to fill P, we need to fill Q, we need to fill RES based on what was, I think this is O2, sorry. And then you don't forget to do a dot N, okay? And if you want, by practice, we should also halt like in each of these if you want. That's a little better. I had a typo here. Question?
Oh, so when it came to a negative one, we required way more coding than the equal and the positive.
Yep. So the only one that has that needs a little bit more is the subtraction, right? Because you got to set up the 2 complement. And when you do that, you wanted to put it onto a separate register so you can subtract it. It's 2 lines. Assuming that that number is, you know, small, but if you have a larger number, you have to have more. Any other questions? Okay, so after you build the program, assemble the program, load it, input, set value, and then run. Okay, so what am I expecting from that? You need to test it with some of these values and then give me the screenshot. Not all of them, but at least a few. I have about 15 minutes. I think I can rip through the next one. Okay, so any question with number 2? If you understand how the number 1 flow, the number 2 is easy too. All right, let's talk about the next one. So there are some questions on the exam that relates to LC3, like I will give you a code snippet and I will ask you what that means. Okay, so make sure we know how to use 2's complement. We know how to do ASCII conversion. We know how values are moved, like store and load, and how we use add, and not. The quiz is 60 minutes for, I think, 10 or 15 questions. They are like more than 5-6 minutes a question. So ample amount of time. Whenever I do my course survey, I ask about that to see if that's enough time. But if you require a special special accommodation, make sure you talk to the DSS people, and then they would send me the thing. But usually students don't require more than 5 to 6 minutes a question, right? So most people said that it's more than enough time that they need per question. So. Okay, let's talk about number 3. We have a little bit of time. How do you address this problem? What would you do first? This is what you're given. D plus C is greater than 10, C is greater than or equal to 10. Clear 2 registers, okay. So good point. So let's say and R1, R1, X0, right? And we wanted to load it. Load R1 to D, right? And then we wanted to clear the next one, R2. I'll start it at least for you. 0. We're going to do an LDI, R2. And we're going to load it to C. Now, what's the next trick? This one is really easy, actually. Let's introduce 10 to the problem, right? Because we already handled, remember what I said, when you look at an equation like this, handle each piece at a time. And you know, like how we look at the parentheses going from the inside the parenthesis and then moving it outward, each piece. So we already got D, we already got C, now we got to handle the 10. Okay, so let's add the 10 so we can compare, right? So Eric says add R3. Oh, and so so we're gonna clear R3. Eric mentioned we should clear R3, X0, and then what? Add R3, hex 9, add R3, hex 1. Why can't you add 10? Decimal 10. Yeah, you can do an hexa. Good point. Because this is a decimal 10. Hexa would fit into the immediate value, so you can do an add R3, hex A. Actually, oh yeah, well, we clear R3. And then what do we do next? I like it. You guys are getting it. I love it. What's next, guys? So add R1, R2. Okay, so you're gonna add D and C together and put it back into R1. Okay, that's fine. I'll do that. R2. So at this point, you have R1 is equal to D plus C, right? And then how do we compare between R1 and R3? Because it's saying that if D plus C is greater than 10, right? We want it to show something. You can have it output anything you want in that. Right? We don't want ASCII conversion, so you can just add like a value to a location and then be able to show it that it's greater than 10. Okay, Eric says, and Christian says subtract R1 and R3, then branch. Okay, or Eric mentioned that then branch on R1 value at that point. Oh, after that you branch on R1 value at that point. Okay, so you need to set up the subtraction, right? Because if you look at this equation, right, if you subtract R1 with R3, what you're doing is you're moving D plus C minus 10, right, is greater than 0, isn't it? Okay. So there you go. That's how you're gonna branch. So take R1 minus R3, check for positive, branch for P, and then, you know, in the positive label, type out what you wanted to show. Okay. So now what we need to do is we need to set up R3 as a negative, right? So you're gonna not R3, and then once come, then we're gonna add R3 with the X1, choose. Then you're gonna do an add R1, R3, like you guys suggest. So that means that R1 is C D plus C minus 10. Then at this point, we can branch for positive. Okay. POS, because it's going to check the R1 for positive, right? And we want it to go, this is if D plus C minus 10 is greater than 0. Then go to pos. Okay, we have a few minutes left. Let's see. Let me double check. C is greater than 10. C is equal or greater than 10. So how do I handle that? So in the positive section, what do we want? We want to, let's say, we can clear another register and then have that register tied to a label to show a number, right? So we can say and R4, and hex 0, clear that register, and then we can add R4 with the hex 1 to display, right? 1 if show 1 if positive. And then we're going to do an STI R4 to, let's say, another label. Let's say RES. Okay. Store to RES. And make sure we fill it, of course. Okay. And we know that the problem told us that C is equal or greater than 10. So it has to be 10 or higher. So likely that it's going to branch to the positive. Should you check it for negative? Okay, while I wait for you to answer that.
Yes.
Why is that?
I believe one of the conditions says, let me look at it real quick.
Because also you wanted to check for C, right? It's important that you also check for C, isn't it? Because the problem calls for that. So remember that your C is in register 2. So you can also check for C. Okay. So if you wanted to go to and test for negative, you can say neg, right? If D plus C minus 1 minus 10 is less than 0, go to neg. And if you want, you can do the 0. But now what we're missing when we're checking for C is, if we want to force the input to be equal to 10 or higher than 10, then we need to check it. Okay. So at one point we have to get 10 to R2 and then have R2 check for 10. Like that means we subtract 10 from 10 to get a 0. If it's equal to 0, if it's greater or equal to 0, then we would have C is greater or equal to 10. So this kind of complete the part where for the DC portion. Okay, then you can enforce the input earlier on. That's really up to you, but the condition that it states here. So when we load R2 to C, what you can do there is you can force it to check for C is going to be greater or equal to 10, which is R2. before you started adding all of subtracting or adding B and C together. Does that make sense? So here you can even have like a R2, oh, I'm sorry. With the hex A, or if you wanted to check for the 10 already with the R2, it's also another approach, right? And then subtract that to get to branch a 0. And then if you branch a 0, so we can do a negative on this, so not R2. R2, and we can do add R2 with the 1. So here, this right here, check for C is greater or equal to 10. Question? So Eric says BRnz, you can do BRnz, you can do R3 has a -1, so we can add R2 to R3 together to check for greater or equal to that. Yeah, you can do that too, because you already have, we already talked about how we would have a -10 already here. So do we really need, so I like that actually. So it saved me 2 steps. So here you have C is equal to +10 or A, right? For hex A. And then if we subtract, if we add these two together and store it into another register, then we can, oh, down here, let's see. So we can do an add R4, R3, R2. I'm just editing my code because I think we need to check for that earlier. So here we can check if C is greater and equal to 10. And if it is, we would branch, right? And Z. And then we can call this, you know, C pos or something like that. And then you got to write that section. So if you want to finish 3, you don't have to finish 3. I will finish the rest of it, and then we can pick it up the next lab and we can talk about it at the beginning. But, you know, challenge yourself to finish 3. It should be an easy one after this point. So, okay, so 1 and 2 is required. Finish 1 and 2, work on 3. I'd like for you to work on 3 if you can. Type your name in the chat. If you have any questions, stick around. And if you need some help, make sure you see me during office hours or make an appointment to see me. I'll walk you through it. Bye. Have a good night.
Good night, Dr. K.
Bye, Ryan. Okay, let me stop sharing in case you have questions.
Hey, Professor, I have a question.
Sure.
So before the lecture, I kind of overheard you talking about like there's a counselor to help you job search, and I was wondering if I could get more
Oh,
information.
yeah, that's right. She's her name is Nikki Cook. I'll type in her email for you. She is a job placement coordinator at Moreno Valley College. I know every college has one. I'm not familiar with RCC or Norco. You can probably reach out to the CTE department or the dean for CTE or SEM out in Norco. And I'm trying to think who is that. But or the chair there and ask, like, I know at RCC you can reach out to Janet Lair. She's usually very responsive. She can point you to the direction. But for Moreno Valley College, Nikki Cook is the one that can help you with resume, how to do job search effectively. She can give you some details on who's hiring and who's not. If you need help with, like, you know, mock interview or something, prepare for your interview, she can help you with that.
Okay, thank you so much.
You're welcome. Other questions?
Oh, Professor,
Yes.
I just wanted to check to make sure. For the first exercise, when we
Mhm.
do the set value,
Mhm.
when we set register 1 to value to the hex 1 and register 2 as hex 2. I know, like, it says, like, get the result at register 5 when you run it.
6, I think.
Oh, 6.
Yeah, 6 store back. If you
Okay.
look at the later in the code, it shows you 6 store back.
Okay. Because so far I think I got a 0, like, for both of them, from what I remember.
But how did you store back to show? So in the 6, it's not going to show the result. It's going to show what you tell it to display. You see what I mean? Because 6 means Z. 6 is Z.
Mhm.
And then you can
Okay.
also find Z location and do the calculation to check. But you store 6 back to Z.
Got it.
Okay. And
All
if you
right.
have a 1, a 2, a 3, it means, you know, it means different thing. If you have a 3, I think that's a positive, right? A 2 is a negative and a 1 is a 0. So if it's
Okay.
showing a 0, something is funky, something is missing in somewhere in your code.
Okay.
Okay.
All right. I'll take another look at it.
Okay. If you want me to, I can have you share screen and I'll look at it for you.
Okay.
Okay, 1 second.
Let me just reset.
Wait.
Okay. So we're gonna start with this guy right here.
Okay.
Let's see.
Okay, let's see this one. All right. So I set the values up already, are register 1 and
Mhm.
register 2,
Mhm.
and I already have it assembled.
Okay.
So I just click run afterwards, right?
Mhm.
Should register 6 be this, or
Yeah, so it clears it out. Why is not? Go to your by Beethoven. Go to, let's see. Go to your label Z. I think it's 3302. Yeah.
right here?
All right. So 31. So that should be hex. So it stores it. See how it shows you the store for hex 2F4C?
Mhm.
Yeah.
Oh,
So
go there?
what that would be is that it's gonna be Z is gonna be at that location. So let's see. I don't think you're gonna be able to see it on this one.
Got it.
Yeah, somehow it's
Let me just give it a try.
yeah, it's not gonna show. It's actually that value when it stores it out. So I think that it clears out your R1. That's a -1. Yeah,
Okay.
that's a, see how it says that sign 1?
Yeah.
And then it clears out your R2 and your R6 doesn't hold it. It stores it to that. Let me play with the online simulator a little bit with the set. I'm not familiar with how they had it set up. It could
Got
be
it.
that it clears it out and it puts it somewhere. So
Yeah.
I'll give you a better answer probably on Tuesday when we revisit.
Okay.
Okay.
And I tried to download the one for Windows, but for some reason it said something was there already.
Oh, then if you already downloaded, you just have to, if you go to your download folder and then just unzip it. So,
Or let me
yeah, so
let me
go
go.
to your file manager. You
Um,
downloaded already?
I tried to, but I think it always tells me something like my
Go ahead.
antivirus always stops it.
Oh, yeah, that if you use McAfee or there are some antivirus that prevent it from coming in. It sees it as a threat. So you
Got it.
you need to disable it. Yeah, one of my students used Symantec last semester and he couldn't open it because it's an executable and it might see it as a threat.
Got it. Let me see.
You can try it now. Yeah.
Okay, let me see.
Yeah, okay. So you using Windows right now, right?
Yes.
Okay, go to your downloads folder, go find your file manager,
Okay.
open that up.
Would it be this one?
Yeah, so click on accept the risk on your browser. See how that message pop up, security alert?
Mhm.
Go ahead and click accept the risk.
Oh, let me see
Go
another
back to your
program.
browser.
Got it.
Okay. And I don't think you sharing your, yeah, click accept the risk to the
Oh,
left
there it
button.
is.
All right, now it should let it. All right, now go to your file manager
Mhm.
and then go to downloads folder.
And then,
I don't see what you're seeing, so I think it's just
oh, I think because I'm just sharing just the one specific window.
right.
Let me stop sharing, just share it again. Let me just do the screen this time. There we go.
All right, go to your down. Yeah, so
I think it stopped it again.
it stopped downloading for you.
Oh, I think my antivirus.
Okay.
Let's
It says
accept
we
the
found,
rules.
yeah, it should let you though. Wait, see details. Yeah, it's a McAfee thing, right?
Yeah.
So I think you have to enable.
Restore, delete files.
Okay, so it's quarantine it. It's containing it. So yeah, one of our,
What?
yeah. So restore there, and then click on the arrow on the right.
Mhm. Oh, I think you're supposed to click it.
Restore. I think that that's the second try. So let's go back and see if it's showing up on the downloads now.
Okay.
There you go. Yeah.
I wonder why. Let's see. Let me try. Let's see.
Says
Let's see.
what about you do run as administrator? Is it gonna block it too?
Let's see. Oh, it doesn't.
Yeah. So I think what you can do, so Eric mentioned something he gives you a tip right there. It says create an exception folder in McAfee so that it doesn't scan the folder. Copy the zip file there and extract it at set an exception folder. This way the antivirus will ignore that
All right.
folder.
Create an exception folder in McAfee so it doesn't scan that.
Or what you can do is you can disable McAfee for that. Like you can turn off all the scan and
Okay.
then run it. That's what I had to do when I was running one of the things for my Python class.
Hmm.
And then after I run it, I turn everything back on. So you can do it that way too.
Okay.
Yeah, so you can try it that way, or you can make an exception folder.
Okay, how would I do that?
To do what?
The
do the-
exception.
So first make a folder.
Just go McAfee.
Is
it this one?
Here, I'll send you a link for it. There's
Okay.
it talks about it in their support.
Okay, I'm just gonna stop sharing real quick.
And that link gives you the information on how to add it.
All right.
It says you're gonna do open McAfee and then I guess real-time scanning settings, exclude files, and then you're gonna add the files to be excluded and then apply. So if you read the second thread, it shows you on how to do that.
Okay, second thread.
Yep.
All right. Open McAfee user interface, real-time scanning settings, exclude files, add.
And it
Okay.
might label things differently, so you can try that. And you know, that way it just allow that file, I guess. That's what you're doing.
All right then.
Okay. Anything else?
No, I think that's all. I'll give that a
Okay.
try.
All
And
right.
if I do face any further problems, what should I do?
You should email me. That's the
Right.
best way. Or you can, you know, show up in office hours or make an appointment.
All right then.
All right. Talk to you later. Bye, Eric. Thanks for your help.